Okay, you have a tank, right? And you have a drain in the bottom, and it's a turbine. A water-powered electrical generator. The water goes through it, turns it, it generates electricity. And we have a pump. It pumps water into the tank. It needs electricity too to function. So we have a pump and a turbine. One needs electricity, one creates electricity. The most you can do is break even, they say. You know what? I'm not even going to argue with that at this point. Fine, let's break even on those. Shall we? Okay. Now add a water wheel up here. In fact, add 3 more. They should work until the tank is at least half full, right? Now we have 2 generators using the same one source of water. We've just doubled our output, and we were breaking even before. Now we have the Perkins pool. So we fill up the Perkins pool with water, and it spins all the water wheels as it goes in until the pool fills up. The water wheels generated electricity while the pump needed electricity. We've just broke even. Now we have a pool full of water and a turbine which generates electricity. So when we drain that pool, after breaking even, we're generating a whole bunch of extra electricity. Golly gee, that doubled our output. Where'd that come from? How did we do that? We just doubled our energy. We're getting out twice what we put in. No, I'm not done. Now put a 1,200-ton barge in there. Yeah. Now fill it up again. Okay, we're breaking even on the water wheels. Getting our electricity back right there. And golly, the barge is floating like any ship would. Okay, now let's pull the plug and let all the water go through our turbine so we can double what we put in as far as electricity goes. Okay, now we just got back double the electricity we put in. Once from the wheels and the second time from the turbine drain. But golly gee, what's that? It's a 1,200-ton barge suspended in midair, just hanging there. 1,200 tons and gravity ready to work for us. So we'll let gravity and that 1,200-ton barge spin a generator for us as it comes all the way back down. And a few hours later, when the barges come all the way back down, well, we're ready to start all over again. Now we've tripled our input. Okay, we're getting 3 times out what we put in as far as electricity goes. No, I'm not done. Now put a big beach ball in there, a tough one like a buoy. It floats too. But unlike the ship, this will do the work as it floats. It can keep the ship company. And on the way up, it can stretch a heavy-duty spring which will store energy in the spring. And that cocked spring will be ready to work for us when we need it, at no extra cost. No, I'm not done. You see, that tank is a lot heavier when it's full of water. That weight can work for us too. We could have the whole tank on massive heavy-duty springs. So as the tank fills up, the weight of the tank will slowly push down on those springs and cock them. Then when the tank empties again, the tank will be much lighter again. And those leg springs will be ready to do some work for us too. They can slowly push the empty tank back up with ease so they can spin generators too. No, I'm not done. Sure, we have 5 times the power now. Our output is 5 times what our input was, but now we can add a pulse circuit and send a pulsing current to that pump. A pulsing circuit will turn it on and off really fast, rapidly, repeatedly, hundreds of times a second. But nevertheless, it's going on and off and on and off. Therefore, it's only using half the energy now, because half the time it's off. But each pulse is like a surge, which increases the torque of a motor or a pump. Therefore, the work of the pump doesn't suffer at all. Yet now the pump is using half the energy it needed. So we just doubled our 5 times the output. Now we're getting 10 times out what we put in. No, I'm not done.
Where's all this water going every time we empty the tank? It's going into a tank too, isn't it? A holding tank. To be used again. And it's getting filled and emptied too, each time, isn't it? By the same pump, at the same time. So, we just put the same identical apparatus down here. And Viola, we just doubled our output again. Now we have 20 times the power we put in. I could probably go on, but I think you get the idea, huh?
However, if you wanted to go the slow route with no electricity, you could use an atmospheric engine, shown here with a glass bubble. In places with a hot climate like a desert, the air inside the tank will get hot real quick. And when it does, it'll expand, but it's got nowhere to go, so it pushes on the water, because the water does have somewhere to go. And it'll pump the water for you all day long. And it doesn't have to be glass. It can be a big black water tower, because black retains heat. And heck, they got big water towers anyway, painted white so they don't get hot inside. Now you know why. And it doesn't have to be a desert. It could be any hot climate. Huh? What? Why, yes, I do have to talk this way. And if I told you why, you'd be insulted. But that's another story. Right now, we were just proving that you can get more out than you put in. Kind of like the government and the bankers when it comes to money, or effort, or work, or any contribution whatsoever. So basically, what we've proven here today, kids, is it's really called the second lie of thermodynamics. Here you see, over unity, that means free energy, getting out more than you put in a simple neon light transformer power supply. If you do the math, you'll see more is coming out than what's going in. That's free energy. That's extra energy, extra electricity. See, every time you double your voltage, you cut your amperage in half, and vice versa. This little simple device with some copper wire in it. This was just to prove free energy is possible. You don't even have to go through all this or build something so extravagant.
I'm Kevin Charles Perkins, and I hope you've enjoyed the show. I just wanted to show people that it can be done. And this attitude of mine is for the naysayers, the spies who work for the power companies, and come in here quoting the second lie of thermodynamics. This attitude is for them, not you, my beautiful fans. For you, much love. See you next time.